There are basically three steps that we are going to follow, and the first one is the base case. So base case is when n is equal to 1. Okay, so remember, this is a formula. I mean, when we add all these terms, 3 to the power 1, we're increasing the power by 1, right? And when we add all of them, it is just the same as taking this ratio. And the claim is that this is true for all natural numbers or all integers, right? So the question is it true? This is what we want to verify. So when n is equal to 1, this is just 3 to the power 1. The question is this equal to the right-hand side when n is equal to 1? So I will write 3. Okay. So the left and the right-hand side are the same. So meaning that this is true. The next case is our hypothesis or an assumption. So we're going to assume this is true for k equal to n plus 1. Meaning that what are we going to have? We're going to have that 3 to the power 1 plus dot 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 plus, 3 to the power k is equal to 3, then 3 to the power k minus 1, everything over 2. So that is what we have. But now we want to, so we're assuming that this is true. So if this is true, then it must also be true, because remember, n can get as large as it can. So if it is true for all the values of n that are okay, n that are greater than 1, then even if we add 1 to that number, say it is true for 10, then when we add 1, which is 10 plus 1, it must also be true. Okay. So what does this mean? So this means that then we want to deduce that it holds. So I'm just writing in shorthand that it holds for n is equal to k plus 1. Okay. So what does this mean? It means that we want to show that this expression that we have written on top, we can write it as 3 to the power 1 plus 3 to the power 2 plus dot dot plus. So remember, we have 3 to the power k, which is which is our assumption. Then we want to see if we add 3 to the power k plus 1, we add one term, is it also going to be equal to 3, that is 3k plus 1, okay, minus 1 over 2. Okay, is this going to be true? Right. Now, there is a simple method that we are going to use. Remember, we are only adding one term to the last term. Okay, so the method that we are going to use is this. Look at this. This term, this is sk, the sum of all the first k terms, and this term is a k plus 1. Okay, that is the nth term, and this sum, which is this side, is sk plus 1. All right. Now, to this term, remember, for you to find sk plus 1, you need to add the ak plus 1 term to this sum, right? So therefore, that is my claim, that we can write sk plus 1 term as sk plus ak plus 1. So let us go ahead and find this sum and see if it is going to give us 3 into this sum. So take a snapshot and we continue. Sk plus 1, that is the last term, is equal to, so we are going to write sk, which is 3 into 3 to the power k, okay, plus 1, everything over 2, then plus the ak plus 1th term is just 3 to the power k plus 1. Say this is 3, I'll write it in steps, plus 3 to the power k, then minus 3, okay? I just distributed, then over 2 plus, now this is a fraction, so I can write it as 2 multiplied by 3 to the power k plus 1 over 2, okay? So this is just a 1. I want it to have a common denominator, right? So this is just the same as. Now on the laws of indices, I can add the powers since the bases are same. So plus 1, then minus 3, okay? Then plus, this is 2 multiplied by 3 to the power k plus 1. Everything I divided by 2. I divided by 2. Okay, now what do we have? What we have now is that, so this is equal to, now on the first one, I have 3. I'm going to factorize, so like terms together. So this is 3k plus 1, okay? And then I write in parentheses like that. So here I remain with 1, okay? This is 1, then plus, here I remain with 2. This is 2. But remember we had minus 3, so minus 3. Then we divide it by 2. So this is just, this is a 3. So this is just a 3 multiplied by 3 to the power k plus 1, then minus 3, everything over 2, okay? So remember, what we want is to have 3 into 3 to the power k plus 1 minus 1, okay? So we are going to factor out, let us just go ahead and factor out 3. 3 outside, 3k plus 1 minus 1. Okay, I just factored out 3. Then everything divided by 2. Then we are done, right? Remember, for the principle of mathematical induction, what is very important is this last step, okay? To show that sk plus 1 can be written by that. Then if you can show that this last term can be obtained from this sum, then you are done. So we end here, take a snapshot, and remember to like, share, and send us a comment where you are watching us from.